Hello, I'm your host, Yohannes Lamere. Welcome to Earth Optimism. We have been discussing specific areas of conservation science, and one of the key factors that contributes to the success of all aspects of conservation is the idea of collaboration. It is not just the work of scientists or students or governments. It is the combined efforts of everyone that leads to success and ultimately optimism for our planet's future. One of the exciting developments in recent years is the activations of big thinking across the globe. People working together across the planet to scale projects, share knowledge, and create new ways to save and restore species and ecosystems everywhere. Let's explore big thinking and some of the exciting developments that are happening around the world. When we discuss big thinking, it is hard to think bigger than space. Scientists at NASA have been using technology from out in space to help inform a variety of research and data on Earth.
Just prior to the subsolar point on the south side and the floor of it, in the evening, there is one dark hole. Oh my God, look at that picture over there. There's the Earth coming up. Wow, is that pretty? Oh, that's a beautiful shot.
Now, let's come back down to Earth and look at ways science is implementing big thinking under the sea.
I think it's difficult to preserve something that you don't understand, that you can't really get a good handle on how it functions. A lot of these systems, unfortunately, are seeing declines in health over the past couple of years. And really what we're trying to do is get a solid handle on how these systems are interconnected, what makes them function properly. You really can't preserve something effectively if you don't understand how it's going to change.
One of the important things about marine geo is we're not only trying to document that change, we're also trying to really understand the patterns and the processes that are driving that change.
Marine geo is interested in taking a pulse on the life of the world's oceans.
You see lots of projects start up in different areas, and they're usually around for a few years. It's the rare project that starts up and intensively studies an area for 5, 10, 15, 20 years. That's what's special about Caribou. It's been used as a research station since the 70s, and it's still going to this day.
So Caribou Key is a special place. It's home for a small group of scientists for a week or more at a time.
It sits 14 miles off the coast of Belize, and it essentially sits right on top of the Mesoamerican Barrier Reef.
Last year was kind of our first Caribou campaign. So this year we're back.
We're collecting fish data, coral recruitment data. This year, for the first time, we're doing habitat mapping on a larger scale.
We're looking at coral reefs, mangroves, and seagrass.
All these ecosystems are intimately connected to one another, and they rely on one another for their health and stability.
Seagrasses are the lifeblood of a lot of coastal environments. Unfortunately, seagrasses are declining at a global rate of about 7% per year. My goal as a biologist with the Smithsonian and part of the Marine Geo campaign is to help establish their seagrass monitoring research. Part of our research involves conducting surveys, and we can also actually get a lot of information about the environment from looking at the chemistry in the seagrass tissue itself.
On this field campaign for Marine Geo at Caribou Key, I would say I have several objectives. Conduct the ongoing long-term research, to scout sites for future research, and also to initiate a new experiment.
Another goal of this campaign is to deploy process assays. So for this, we've made what we call squid pops and weed pops. This is important because it allows us to compare cross-habitat types and see how fish consumption varies from place to place around Caribou. The information that Marine Geo gives us will allow us to ask more detailed and pointed questions in the future about these different types of habitats.
And we already know from the way that we're looking back at data from several decades ago that the data we're collecting now will be used to answer questions that we can't even anticipate.
Human population is growing, and there are increasing number of stressors and impacts to a lot of these coastal areas. And so what Marine Geo wants to do is really understand what is happening, how our systems are changing, and what we could possibly do to prevent or mitigate that change.
I'm so pleased to introduce Dr. Nancy Knowlton to our program. Not only is Dr. Knowlton an esteemed marine biologist known for her work in protecting coral reefs, she is also the founder of Earth Optimism. Welcome, Dr. Knowlton. You've been a marine biologist for over 45 years. Wow. What changes have you seen over the time, and how has big thinking impacted science and conservation?
Hi, Johannes. Thanks for having me. 45 years is a really long time. And of course, a lot has changed over that time period. The environment, of course, has changed a lot. I work on coral reefs, and the reefs that I studied as a student really are in terrible shape compared to the way they were 45 years ago. So that's changed. But also, how we study coral reefs has changed enormously as well. It used to be that scientists just studied what they were curious about without thinking too much about any connection with environmental threats. And then, of course, as reefs got to be in worse and worse shape, they started focusing their science on understanding what was going on and what was causing these very serious, troubling changes. And then most recently, in the last decade or so, scientists have really been focused on finding solutions. So not just understanding science for science's sake, but really trying to address these problems and solve them. So that's a big change. And then, of course, the other thing that has really changed is the connectivity of scientists around the world. When I was a grad student working in Jamaica, the only way we had of connecting with other people was either the mail or the telephone, the regular mail, the snail mail, and the telephone. And now, of course, we can connect with scientists using Skype or all sorts of other ways very easily, and we can share information. And that ability to share information is so important because it means that you can put together huge data sets collected by people from around the world. And those big data sets lead to the ability to do big thinking. For example, that video about Marine Geo, it was what you saw were scientists working in Belize. But what's important to realize is that Marine Geo has programs all around the world with different teams of people going out and doing exactly the same thing. And because they're doing the same thing, that data from all over the world can be put together and compared and used in a way to answer really big questions. So yes, big data and big thinking has really increased in the 45 years since I've been a scientist.
What about technology? That must have changed a lot as well.
Oh, yes. 45 years is practically forever when it comes to technology. As I mentioned, back when I was a grad student, the only way we had of communicating with other scientists was by mail or by telephone. There wasn't even email back then. So, of course, technology has really transformed, and not just in terms of these electronic abilities that we have now that we didn't have before. There's all sorts of possibilities to figure out what's living in the ocean using DNA. You can collect literally a glass of water, take the DNA out of the water, make multiple copies of it, and sequence it to find out actually who's living in the ocean. And you can do that over and over again and watch for changes. So our ability to use DNA methods has really transformed our ability to quickly and inexpensively keep track of what life is like in the ocean. And then, as you saw in the video from NASA, we have enormous capabilities with respect to remote sensing that we didn't have 45 years ago. And in particular for coral reefs, it used to be that remote sensing basically stopped at the surface of the ocean. And now, really, just in the last 5 years, it's the case that we can now use special cameras and actually see through the water to coral reefs underneath the surface of the water on the bottom. And that's really changing our ability to keep track of the health of coral reefs remotely. So both remote sensing and DNA methods, and there are many other examples, what they do is, first of all, allow us to collect kinds of information that we didn't have before. And also, even if it's the same kind of information, we can do it much more cheaply and efficiently, which is important because we need that information very badly.
Now we have 2 questions from students in Indonesia who are participating in the U.S. Embassy's English Access Program. Let's see what they have to ask us.
Hi, my name is Wahid and I'm from Gorontalo. I'm an alumnus of the U.S. Embassy's English Access Micro Scholarship Program. We know that the coral reefs have suffered so much. So my question is, what makes you really optimistic about the future of the corals and the coral reefs? Thank you.
It's true, coral reefs have suffered a lot, actually the ocean in general. And for a long time, I wandered around the world giving talks about the terrible state of the ocean and how things were going, getting worse and worse and worse. I was sometimes, my husband did the same thing. We often called doctors doom and gloom for our really depressing lectures. But we came to realize that, first of all, just being depressed about things and not thinking about solutions doesn't get you very far. And that, moreover, there were actually a lot of solutions out there that people just weren't paying attention to. And things there were, I mean, not enough yet, but still there are places where things are getting better. So that has really changed my attitude about optimism and versus pessimism. I even started a Twitter campaign called #OceanOptimism, and that ultimately led to the Earth Optimism initiative that this series is a part of. So I am optimistic, and scientists have many more tools at their disposal to solve problems than they did when I started, and they're also more committed to really focusing on solving problems rather than just studying whatever happened to catch their fancy last week. So it's a lot more commitment and a lot more capability among the scientific community. And then finally, the other thing that really makes me optimistic is young people, your generation, because you really care about the planet and its future. It's your future as well as the planet's future. And that commitment is really important because the worst thing you can have for the environment is apathy. Apathy is a disaster when it comes to the environment. And your generation is not apathetic. You are really engaged, and that makes me very, very optimistic.
Hi, my name is Farhan and I'm from Ambon. I am an alumni of U.S. Embassy English Access Micro Scholarship Program. I would like to ask a simple question. Have you found it hard being a woman in marine science? Thank you.
I haven't personally found it too hard being a woman in marine science. But that's partly because even though I started what seems like ages ago in the 1970s, by then progress had already been made. Before then, it was hard. In fact, women weren't even allowed on research vessels for a long time. So it was hard to be a woman in marine science. But already by the time I was a student, things were getting better. And that improvement has continued to this very day. For example, the National Academy of Sciences, which is the most prestigious scientific organization in the United States, the president is Marcia McNutt, and she is a marine geologist. And so we're seeing a lot of improvement. That's not to say that there weren't maybe a few things in my career that might have gone differently if I were a woman. And it's also not to say that my experience is not necessarily universal. There are certainly women marine scientists who have had a hard time. But speaking personally, I've been, I guess, relatively fortunate. And things are really improving generally for everyone, not just for me, as in the last several decades. I think where we need more work, where we really do still have a serious problem, is with racial and ethnic diversity. But even there, the spotlight is starting to focus on this, and really serious thought and actions are being taken to rectify those problems as well. So, yes, there are problems, but in general, I feel things are going in the right direction.
Dr. Knowlton, thank you for your commitment to conservation and your work to protect coral reefs over the years. And thank you for sharing your vision of Earth optimism with us and the world. We really appreciate you joining us today.
Thanks. It's my pleasure. I really enjoyed the conversation.
A great example of organizations and science coming together for a common goal is the Reverse the Rat project from IUCN, the International Union for the Conservation of Nature. Here is an update on this project.
Every year, thousands of experts evaluate the status of animal, plant, algae, and fungi species around the world. Using a common language of assessment, they categorize each species' risk of extinction on the IUCN Red List. The Red List provides a barometer of life. And every year, the outlook gets worse. More than 31,000 species are currently threatened with extinction. Most because of human action. But human action can also reverse the Red List trend. So conservationists, governments, and communities around the world are joining forces, activating tried and tested IUCN tools in a coordinated effort to assess, plan, and act for wildlife. Together, we can save species from extinction. Together, we can win the fight for our planet's future. Together, we can reverse the red.
All of these advances require new technologies to support their efforts. Let's take a look at how drones are being used by the Smithsonian's team in Panama to assist their research.
Today, we're flying a fixed-wing drone at 290 meters. Since the 1980s, we've been doing a census of trees on Barrio Colorado every 5 years, but from the ground. Now we can see this change through time from a different perspective. Today, we'll take between 1,200 and 1,300 images. The program melds the images together to create an orthomosaic, or one complete photo of the entire island. With this technology, we can see how much a tree has grown and what its diameter is. We can see the dynamics in terms of the production of leaves, flowers, fruits, and tree falls from above. This is a technology that is evolving at great speed in the environmental sciences. Okay, mission complete.
Every morning, a small riverside community in central Kalimantan, Borneo, rumbles to life. The commuters are caretakers and teachers at a local school, which happens to be one of the most unusual in the world. It's called Nyaru Menteng. The lessons taught here aren't in math or science, though. They're in survival. And the students are orphan orangutans. Just over a mile up the road is the Nyaru Menteng Nursery School. This is where the youngest orphans begin their journeys. Cuddling together in these baskets takes the place of their mum's arms at night. At 6 a.m, Rona has a bad case of bedhead. Mima is ready for anything. And Bawan and Napri are good to go. Diapers are used overnight for the same reason human babies wear them. And every morning starts with a bottle. In the wild, these 2 to 18-month-olds would be nursing numerous times throughout the day and night. Here in the nursery, the infants drink a special soy milk formula, which is better for their digestive systems than cow's milk. These babies may be small, but they already have big personalities. There's enough formula to go around, but Boomy wants to dominate the bottle. Breakfast has got 11-month-old Kalanis all fired up. A human baby of this age wouldn't have as many teeth. But there's something similar about the game he plays with his surrogate mum.
I'm excited about the large-scale projects and collaborations that are happening right now around the world to save species and ecosystems. And it seems that humans have the ability to make the necessary changes to support these efforts. We can all participate in Earth Optimism. To learn more, please visit our website, earthoptimism.si.edu. Thank you and see you on the next episode.